Greetings and welcome to my new calculus channel. So, you've obviously heard a lot of fools in the mainstream, especially that idiot Professor Jack Huizenga from Harvard. He's actually an ex-Harvard alumnus, claimed that this here is similar to the finite difference, to the central difference. Of course, he retracted his critique because he knew it was wrong. But in any case, I'm not going to focus on that idiot. What I want to tell you is that one of the most popular critiques aimed at the new calculus is that it doesn't allow inflection points or derivatives at inflection points. Well, that's actually not a weakness, it's a strength. Now, in the new calculus, you'll always have the general expression for derivative, which is this, okay? So whether you have a tangent line there or not, you still get the general expression for the derivative, except that the only pair which will satisfy Q of xmn, which is the auxiliary equation being zero, would be the 0, 0 pair. In other words, what that means is that you need a secant line like that, which is impossible, okay? And this is based on the mean value theorem, so you can't have this. It's not allowed. But if you want to have a half tangent, it's very easy. You simply put m equals to n equals to 0. But of course, it's not a problem because the mean value theorem, now pay attention, morons, the mean value theorem of calculus, this is the mean value theorem, which allows you to calculate areas, volumes, hypervolumes, etc., doesn't give a hoot about inflection points. So I'll give you a few examples. So here's a cubic and here's a quadric. And it doesn't matter which function you can use. You can use transcendental, trigonometric, it doesn't matter. The mean value theorem ignores inflection points. So for example, if you take this curve here, this this fourth order polynomial, okay, a quartic, this one, and you calculate it from 2 to 3, you will get 14.95 square units. And of course, the inflection point is here at C. So if you calculate the integrals from from 2 to C and from C to 3, you'll get the same value. Can you see that the mean value theorem doesn't care about inflection points? Right, morons. Same thing with the green curve. There's an inflection point here at A, right? This point here, which is 1, 5. And if you take an integral from 0 to A and from A to 1.2, you'll get that, okay? And of course, if you just simply have to take the full integral like this, from f0 to 1.2, you get the same value, okay? There it is. So as you can see, the mean value theorem doesn't care about inflection points, all right? So now we can actually get rid of all that and even that and that, okay? And we don't really care about these. And you can try any old function you like, all right? Let's try f of x is equal to 2 times sine of x minus 3 plus 1. Okay. Now, where did that go? All right, there it is. Okay, so there's your function. Now, maybe we could just jack it up a bit more. Let's make it about 4. There you go. So there's obviously an inflection point at many places. Let's just get a few. Inflection, I don't know how this is going to work because I've never done it before. F. You see, it's because there are too many. But there is an inflection point somewhere here, as you can see, where the graph changes concavity. So if you had to take the area from minus 1.5 to, let's say, 1.5, so you'll say integral of f from minus 1.5. Let's make it to 1. Doesn't really matter. Now, what did I do? I think I entered the wrong number of variables. Okay, let's try this again. Stupid GeoGebra doesn't allow you to do this, doesn't allow you to get to see the value if you type it in wrong. So f from minus 1.5 to say 1. Okay, that's the whole area. So if we had to take the product on the sum of these separate areas around the inflection point, and I'll leave that to you as an exercise, somewhere around there, then you'll find that it will come to this value too. So don't listen to the critique that you hear about the new calculus. It is the first rigorous formulation of calculus in human history, and the only so-called refutation they hold is not a refutation, it's a strength. And why is it a strength? Because if the only Mn pair that satisfies the auxiliary equation is 0, 0, you know that there is an inflection point there. Compare that with the drivel that you have to do in mainstream calculus with the first derivative and the second derivative test and all that garbage. The new calculus is not only simpler, it's more elegant, it's more powerful, it has many features that are not possible using your mainstream definition of derivative or integral. That's right. For example, the Gabriel polynomial. You cannot use your mainstream definition therein because it will fail. You can only use this definition of derivative. That's right, this. Okay? So, and I don't know if any of you noticed, but you can discard this part entirely because this side is exactly equal to the derivative. And that's pretty much it. My name is John Gabriel. If you're not already a subscriber, become a subscriber, tell your friends about this channel, and follow me on academia.edu. Till next time, goodbye.